awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. Welcome back to my channel. Jadi jika anda pertama kali hadir ke channel ini, selamat datang saya ucapkan. Tapi jika anda pernah hadir dan kembali semula, terima kasih kerana sudi kembali. Jadi dalam video kali ini kita akan buat beberapa examples berkaitan dengan conservation of energy dan juga power daripada chapter 5. Jadi apa tunggu lagi? Jom kita mula. Okay, untuk example number 1. So here we have a parcel is launched at an initial speed of 3.0 meter per second up a rough plane inclined at an angle of 35 degree above the horizontal. So means that for this question, we have an inclined plane. So cuba kita lukis satu inclined plane. So let's say this is the inclined plane. Okay. And then we have a parcel. So let's say the position of the parcel is here. This is the initial position. And then the parcel will move until this position. Okay. So the direction of displacement in this direction, since the object will move up on the inclined plane. Alright, so now since this is the angle, so given that the angle theta is equal to 35 degree, so we need to draw the free body diagram first. So we're going to have weight straightly downward. Okay, so this is y component and this is x component. Okay, so since this is a rough surface, so we're going to have frictional force which is opposite direction with the motion. So dia bergerak ke atas, so frictional force mestilah bertentangan. Okay, so for example in this direction we have frictional force, and at the same time we need to resolve. Okay, W into WY, so this is the angle of 35 degree, and resolve into WX. So kita boleh nampak in X component, we have two forces which is opposite direction with S, which is WX and frictional force. Okay, so the question gives us the coefficient of kinetic friction mu, which is equal to 0.3. Alright, and the initial speed of the parcel is 3 meter per second. Okay, so here is U. And then determine the maximum distance traveled by the parcel up the plane. So we want to determine what is the maximum distance S. So bila kita kata maximum distance, okay, bila kita nak cari maximum distance, means that dia dah sampai ke atas. Okay, so parcel ni dia akan sampai ke atas sini. Lepas tu dia akan stop lah. Seolah-olah dia akan stop dan dia akan patah balik turun ke bawah. Alright, so when the parcel reach the maximum distance, we must know that V here is equal to 0 meter per second. Okay, so for A, we want to determine what is the value of S. So from the information given, we can see here there is a change of velocity. Kalau initial velocity is 3 meter per second, so when the object reach the maximum distance, so V is equal to 0. Okay, so saya akan tulis work total. So I'm using the work energy theorem. So W total is equal to the change of the kinetic energy. Okay, so saya akan kaitkan dengan equation ini, di mana work total is equal to F net cos theta. Sorry, F net S cos theta. Okay, so when we substitute here, work total is equal to F net S cos theta is equal to K final minus K initial. Okay, so kalau final velocity is equal to 0, so means that kinetic energy, okay, final kinetic energy is equal to 0. Okay, so sekarang kita nak cari nilai S. Okay, okay, yang ni kita boleh masukkan nilai, tapi kita perlu lihat F net. Okay, what is the total force on the object? Okay, so based on the free body diagram, okay, kita ada Wx dan juga Wy di sini. Okay, which is Wx opposite direction dengan S, friction pun opposite direction dengan S. Okay, so sekarang kalau saya lukis, okay, so let's say this is the Y component and this is the X component. So the object is moving in this direction, right? Okay, so we're gonna have frictional force, and then let's say I take another color, and this is Wx. Alright. Okay, so let's say we want to write the equation of net force. Okay, so in this case, we can write that F net is equal to negative Wx, since Wx opposite direction dengan motion ni lah. Sepatutnya S ke sini, okay, V dia pun ke sini lah. So negative Wx plus negative friction. So total net force on the object. Okay, so we can write Wx is equal to, so chapter 4, Wx here is negative mg sin theta. Ingat so ini adalah W. Kalau sini adalah angle dia 35 degree. So yang dekat dengan angle adalah cos. So Wy adalah W cos theta. So Wx adalah W sin theta. So dia akan jadi negatif mg, saya terus masuk saja W equal to mg sin 35 minus friction. So friction, remember equation mu kn. Okay, sebab kita dah ada mu tadi kan. Okay, so kita dapat satu equation. Alright, tapi tengok dekat sini kita ada normal force. Kita nak dapat daripada mana? So normal force duduknya di Y component. Okay, normal force duduknya di Y component. Okay, so referring to the Y component. Okay, so we can write total letak atas ni total Fy equal to 0. So we have n plus negative Wy equal to 0. Therefore, normal force kita boleh gantikan dengan mg cos theta. Okay, so let's substitute here. F net, okay, is equal to negative mg sin 35 minus mu kita adalah 0.3. Okay, 0.3, and kita adalah mg cos 35 degree. Okay, so kita boleh factorizekan equation ni sebab kita tak ada nilai mass. M kita tak ada. So saya akan tulis negative m. Saya akan selesaikan. Okay, g sin 35. So let's substitute all the values. 9.81 times sin 35 minus 0.3, okay, and then 0.3 times 9.81 times cos 35 degree. Okay, so yang ada nilai tu kita dah boleh selesaikan siap-siap. Kita boleh selesaikan siap-siap. So kita akan, ini akan jadi plus lah. Okay, sebab kita dah factorizekan negative m. Okay, so we need to solve for the calculation in the bracket. So, you akan dapat F net is equal to negative 8.04. Okay? Bukan meter This is M. Negative 8.04 M Newton. M tu kita tak tahu nilai dia berapa. So, saya letak saya punya F net in terms of M. Okay? So, why we have negative here? Okay, since the direction of the Wx and frictional force is opposite direction, which is to the left. Okay, so kita dah dapat F net. Alright, so now we want to substitute in this equation. F net as cos theta equal to negative Ki. Okay, sebab Kf kita dah cancel out. Okay, sebab V equal to 0, final kinetic energy also equal to 0. So now F net kita, okay, kita tengok direction dia. Okay, kita consider F net in this direction. And then, kita ada S in the opposite direction. Okay, so the angle between F net and S is 180 degree. So, kalau saya masukkan nilai dia, F net, saya consider magnitude dia adalah 8.04. Okay, S kita nak kira. And the angle between theta and the angle between S and F net is 180 degree. Okay, so kita dapat negative half mu squared. Okay, so ini tertinggal M ni 8.04 M. So sebab kat sini kita boleh cancel M. Okay, so here we can cancel M. Alright, so we can substitute. Okay, 8.04 cos 180. Okay, 180 is equal to negative 1. So we're going to have negative 8.04 S equal to negative half. U is 3 squared. Okay, so now we can cancel. Therefore, S is equal to 0.56 meter. Okay, so kita dapat jawapan dia S equal to 0.56 meter. Means that the object is travel from here, from the starting point to the ending point here, and it's equal to 0.56 meter. Okey, jadi ini adalah cara yang pertama jika kita nak kira menggunakan F-net equation ataupun kita nak kira berasingan. So we can calculate work total by using equation F-net as cos theta, ataupun kita boleh kira asing work total. Macam mana kira asing tu? Okey, kita cuba buat. Saya padam dulu yang ini. Alright, so let's say this time we want to calculate work total here. Okay, but we need to calculate first what is the work done, okay, by the Wx, and then what is the work done by the frictional force. Kita kira asing pun boleh. Okay, tadi kita dah buat cara macam ini, Wt equal to F net as cos theta, ataupun kita nak kira asing-asing. Okay, so since here we have Wx and F in x component, which is opposite direction with S. Okay, so kita boleh kira asing. Kita cuba dulu yang pertama. Let's say we write Wt is equal to work done by the gravitational force, which is Wx plus Wf. Okay, so now look at here. Okay, the angle between Wx and S. Okay, it is 180 degree. And the angle between friction and S also 180 degree. Okay, so we can write here the work done by Wx is equal to Wx as cos 180 degree. Alright, plus frictional force F as cos 180 degree. Alright, so this will be equal to negative 1, and this is also negative 1. Therefore, we can write negative mg, look at here, Wx is mg sin 35, mg sin 35, okay, times S, okay, plus negative, alright, negative mu kn, mu kn S, macam itu, okay. So, tadi kita dah kira kan, the first part where n is equal to, okay, mg cos 35. So, we can substitute here. Okay, kita cuba rearrange the equation. So, kita akan dapat negative mg s sin 35 minus, okay, mu k mg, okay, saya letak mu ks. Okay, saya susun balik. Mu ks, okay, n adalah mg cos 35. Okay, so kita tak ada nilai m, tak apa, kita boleh factorizekan m dan s. So kita ada negative ms, okay, so g is 9.81 times sin 35, okay, plus 9.81 times mu kita adalah 0.3, okay, times cos 35. Okay, awak kira satu-satu. So, we can solve for the work total, and then kita akan dapat, this is in terms of ms, negative 8.04 ms. Okay, ms. Okay, in terms of ms. So, now, W total, look at here, W total equal to K final minus K initial, delta K. Okay, so delta K, kita buat peta sikit. So Wt is equal to negative 8.04 ms. Okay, kita tulis dekat situ. So kita boleh equal to Okay, K final since V is equal to 0. So, K final is equal to 0. Okay, kita boleh kira M, U is 3 squared. So, we can cancel M, we can cancel negative. So, S is equal to 0.56 meter. Okay, so ada dua cara lah. Awak suka yang mana? It's up to you. Mana yang lebih mudah untuk awak kira. Okay, so finish part A. So, let's look at part B. Okay, so now look at part B. So, determine the speed of the parcel when it slides back to the starting point. Oh, sorry. Okay, so bila soalan kata slide back to the starting point, so kalau kita sketch kita punya diagram, so dia akan jadi macam mana? Okay, so kita sketch dulu kita punya inclined plane. Okay, macam ni lah lebih kurang Here is the starting point, where here U is equal to 0 meter per second. Okay, and then this is the final position V. So we want to calculate V, and then the object will travel 0.56 meter. Sebab soalan kata the parcel slides back to the starting point. So S is equal to 0.56 meter. Okay, so as usual we need to draw the free body diagram. So W is downward. Okay, so we have Y component and X component. So since the object is moving down the inclined plane, so means that the frictional force, so saya lukis frictional force mesti opposite direction. Dia bergerak ke kiri, frictional force mesti ke kanan. And then weight you need to resolve. Okay, WY, so this is the angle, and then WX. Macam tu. Okay, so sama je macam kita buat dekat A tadi. Kita tulis WT is equal to delta K. Okay, where WT, you can use the first method, F net cos theta. F net S cos theta equal to K final minus K initial. Okay, so in X component here, we have two forces, WX and frictional force. So let's say we want to calculate what is the F net. So F net would be equal to WX, positive value because WX sama direction dengan S, plus friction opposite direction. Okay, so kalau kita masukkan dekat nilai dia, mg sin 35 minus mu kn. N kita gantikan normal force kita, mg cos 35. Sama macam first part tadi. So kita tak ada nilai m, saya factorizekan dulu m. So g sin 35 minus mu kg cos 35. Okay, so semua nilai ni dah ada, g dah ada, sin dah ada, semua ni dah ada. So we can substitute the values. So you akan dapat nilai F net U adalah positif 3.216 m. Bukan meter m tu adalah unknown mass dia. Okay, so since F net is positive, maknanya direction dia adalah same direction dengan displacement. Okay, so maksudnya adalah displacement in this direction. So F net also in the same direction. Therefore, theta is equal to 0 degree. Okay, so now let's start the calculation. F net, we substitute 3.216 m. S kita dah tahu, object to travel back to its starting point. So S is equal to 0.56 meter. Okay, cos 0 equal to 1. And K final minus K initial. Remember, for this case, the starting point is here. So U is equal to 0. So KI is equal to 0. Okay, so K final ada. So masukkan nilai dia. V kita nak cari tak tahu berapa. Okay, so potong M. Therefore, we can find V final is equal to 1.9 meter per second. Okay, so kita dapat jawapan. Kalau ada kata nak guna second method tadi pun boleh, tak ada masalah. Okay, WT awak boleh kira work done by WX plus work done by the frictional force. Masukkan saja dalam equation WX as cos theta plus Fs cos theta. Tengok angle antara WX dan S. Okay, same direction, right? WX in this direction, S pun sama. So the angle is equal to 0 degree. But friction Friction is to the right, but S is in opposite direction. So, they are 180 degree. Okay, so theta adalah 180 degree. Okay, sama je macam tadi, you masukkan balik dalam sini, nanti you akan dapat WT is equal to, ini boleh jadi mg sin 35, okay, cos 0, mg sin 35 times S plus mu kn. Mu n kita adalah mg cos 35 times dengan S, okay, cos 180 degree. Okay, negative 1, 1. Okay, so you selesaikan, you akan dapat positive 1.8 m. Therefore, WT is equal to delta K. So, WT is 1.8 m. And kita ada K final minus K initial. Since U equal to 0, so K initial is equal to 0. So, sekarang kita boleh substitute terus mv squared. M boleh cancel. Therefore, V is equal to 1.9 meter per second. Okay, kita mesti akan dapat jawapan yang sama. Tak kisahlah you nak guna method pertama ataupun method kedua. Okay, so finish example number 1. So, let's proceed to example number 2.